last week we have discussed about use of microcontrollers. Right, this lesson we learn about what are these microcontrollers and in which condition these microcontrollers are used. That is the first instance we learn about that. And then we have learned about these sensor-based systems and how microcontrollers take inputs using sensors. And after that, we learn how the output is given, how the automatic inputs are taken using sensors that we have learned. And then we have learned about the different devices which use the microcontrollers and single board, single chip devices, then microbit. So we have just learned about the microbit basics. And so today we have to discuss about the sensors related to microbit, this part. Actually, I'll discuss that, but before that, I'm thinking of discussing Arduino as well. Then sensor part we can discuss together related to both microbit and Arduino. Right, Arduino is like developed by a company called Atmel. So they have developed Arduino board, and Arduino board is open source. If something is open source, what can you do with that? If something is open source,
we can do whatever we want.
Yes, whatever we want means what actually, right? But actually, so you can develop another board using this board, right? That means you can see the code and see the circuit, how it is done, and you can create your own one. So that is why you can use, the Arduino came, because Arduino is open source, so it can be like reformatted, and it can be so the way that it is developed can be used, and then Arduino is developed based on the open source mechanism, based on the open sourceness of this. Anyone can develop, anyone can copy this. Simply, anyone can copy the way that they have done. So that is open source. Actually, Atmel, they made this open source. So Arduino is open source platform. Therefore, here you can see Arduino open source. It's an open source platform. Therefore, you can go, you can see the development board, how it is done, and you can see the code as well. There is an open source community for developing and improving Arduino. So you can try your own due to that. Then this is actually not a single board. This is single chip. So why we call it single chip? So even though there is a board, so board is supporting, but everything happens in this chip itself. Let's count the number of pins. Let's count the number of pins. You can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 pins are there. If you count from here 0 to 13, so altogether it's 14. If you count here, there will be 14. Right, there are some additional as well. Additional means for the power pins, other than the power pins, you have ground pins. So there is another ground pin there. So these kind of things are there, but normally, so it is covering these 28 pins around that. Okay, then it has two kind of pins, digital pins and analog pins. Digital pins are taking inputs and outputs in digital format. Digital it has two levels, high level and low level. High O1 and low level. So basic digital can have multiple levels, but basic digital circuit will have two levels, high and low levels, basic digital circuit. So here you can feed that inputs and outputs, digital and analog. So this part is for the digital, digital pins. You can use these digital pins and input digital signals into it, and also output digital inputs, digital outputs. Here there are 14, here there are 14, altogether 28. So just count it, altogether there are 28 pins. So you can use that for digital and analog. So this part is for the digital. Actually, so let's say something is digital, you can see the presence and absence, on and off, 1 and 0, yes and no. Maybe let's say temperature sensor. So if it says the temperature is above this level or below this level, temperature maybe අපිට measure කරන්න පුළුවන් 30ට වැඩිද 30ට අඩුද, two status only. So clearly there is a separation. It's අපි humidity sensor එක ගමු. Humidity sensor එක digital එකෙන් දුන්නොත් humidity එක වැඩිද අඩුද. Light sensor එකක් digital වලින් දුන්නොත් the light sensor sense whether light is there or not, yes or no. So that is the behavior. But here if you sense it using analog pins, there are analog pins as well. A0 to A5, 6 pins are there for analog. These analog pins can even measure light sense එකක් මේ analog එකෙන් දුන්නොත් light level එක measure කරන්න පුළුවන්. එතකොට noise sense එකක් දුන්නොත් noise level එක, humidity sense එකක් analog වලින් දුන්නොත් humidity level එක, ආර්ද්‍රතා මට්ටම. මොකද yes no නෙමෙයි තියෙන්නේ, ආර්ද්‍රතාවය තියෙනවද නැද්ද කියන එක නෙමෙයි. It's measuring the presence as well, but it is measuring the amount of the amount as well. The range can be measured. Therefore analog can give more information than digital. So digital is good, digital is simple, but analog can present more. Then the power pins. So you have ground pin, 5 volt pin, 3 volt pin. So reset, and so these different pins are there. And also V in, voltage in, you can give input voltage there. So DC power, so basically you can provide different power levels, 9 volt, 12 volt, 5 volt even, and the power regulator is to control the power. And then you have USB, that is to send the code, that is to upload the code, and not just that, USB can provide power as well. Code එකක් දෙන්න පුළුවන්, power එක දෙන්න. So both purposes USB is provided. So this is the overview of analog, and it used ATmega 328P chip or microcontroller. That is, it's a microcontroller here. It has a memory, it has a processing power, memory, and also the volatile, non-volatile memory parts. So all these things are there in this ATmega 328P. That is a microcontroller. Okay, I think you have a good idea now about this. So anything else do you want to ask regarding this, or any difficult points? You can ask, right? Okay, I hope then there's nothing, right? I hope then there's nothing. So let's proceed with that. Okay, Puti. So let's do our practical. To do this, actually, you need to have Tinkercad account. If you don't have Tinkercad account, you can create it now. And if you are new to the class, if you don't know how to create this, still I can help you. So what you need to do, you have to tell that you are new. You have to tell that you are new, and you have to then you have to tell that you need help. Otherwise, I don't have superpower like Jnana to see what's happening there, right? So no way, I don't have power of God, I don't have power of anyone to see what's going on there. So if you have difficulty, you have to convey that, tell that. That is not a thing to be ashamed. So USB is used to charge you the power as well as you the data. Electric controller or this regulator is to control the input voltage level, the voltage level control. The DC power supply, it can provide 5 voltage, or it can even provide more voltage based on the regulator. So conditions, so based on the regulator, or using the regulator, we can change it, but basically it will accept 5 volt and above. But don't provide high voltage to this, it will burn the board. So there's power pins, analog pins, and digital pins are there. We saw that. ATmega, this ATmega or ATmega 328P is the microcontroller that is by the Atmel company. And there are different versions of Arduino. That is Arduino Uno, that is general one that we are using now today. Arduino Mega is for the big projects. It has more pins than Arduino Uno. Arduino Nano board is a small one. It has less pins, and it's a less powerful processor there. And then Arduino Micro, it has less interface, and it's less powerful than this Arduino Nano even. So this is used for very small projects. Based on the project, you can decide which one to use. Arduino Mega, definitely it has more pins to improve, and then the Nano and Micro, it's smaller than Uno, right? Or Uno or Uno. So different people pronounce different ways. Some say Uno, some are telling Uno or anything, right? Okay, so let's learn the breadboard principle now. Before we begin, we need to study this breadboard. So let's create the account first of all. Let's create the account. Please log into the Tinkercad account if you have. If you don't have, please create the account. So, okay, I'm in Tinkercad. How can I log in? So let's go to the website first. Let's log out from here and start from the beginning. And if I'm in the Tinkercad, so how can I log in? You know how to do that. I explained already. Yes, please. Please talk. Hello. So how can I log in? Come on, if you're not going to talk, then how can I do the class?
The login button up. Right go.
So this one, login. Okay. Then after that? After that?
Personal accounts.
Personal account, this one. Okay. After that?
Email or username.
Okay, I can use this one. Right? Sign in with Google, that is easy, I think. Email or username rather than using that. Sign in with Google is easy, right? You don't want to create account even. I'll be making it. Sign in with Google. Then it will prompt us some Google accounts. I can select my Google account from that. Gmail account. Okay, here it is. And it's logging in. So shall we log in? Shall we all log in?
So I logged.
Okay. So if all of you are done, please tell me, right? You have to log in first. Do this with me, Pute. Even though you are using your mobile phone, do this with me. Why? Because right, this is required. So when you do so, get the chances. Then online classes, online classes, subjects. But normally you can't do the practicals in online class. You can listen like banana, the banana hanging hanging. That is also I'm not like giving you like I'm not discriminating or like dropping down that, but the thing is, so just listening will not give you any skill other than the by hearting skill and remembering skill, attention. So those things will be developed, but it's not going to improve yourself within. What you have to do is practice. So in Buddha's lessons, so he has explained practicing mindfulness. So not just listening mindful. Listening is a part, yes, but what he was telling, so what is needed is practicing mindfulness. So that is what needed. Just listening won't do much. Therefore, practice this. Okay, everybody, all of you log in, or do you have any difficulty? If you have any difficulty, tell me, then I can help you. Nadun, okay, Gavrika, Ashen. If you're not okay, tell me. Avisha.
Okay, sir.
Right. Then go to create new circuits. So it will prompt this design, right? 3D design. Don't create that. Go to the circuits. So under the circuits, you can go to the create new circuit. Create new circuit. That will give you this empty interface. Let's take a breadboard to that. Here, breadboard. So today we are going to practice about that breadboard. And let me explain the wiring first. The breadboard wiring is like this. So when you connect something here, it is fully connecting this. Everything will be connected. Okay. So if we are connecting something here, there is the entire row will be connected. That means this plus minus is connected horizontally. Plus and minus connecting horizontally. Here also the minus, entire row is minus. Plus entire row is, that means wiring is connected this way. Wire connect. There's a common wire connecting all these nodes. So there is a common wire connecting all these nodes horizontally. But when it comes to the middle part, it is connected vertically. It's connecting 1, 2, 3, 4, 5. 5 pins. Here also the same thing. It's connecting this way, downwards. When you connect something here, you can get another connection from there. That is it. Let's take breadboard now. And first of all, what you have to do is you have to create small circuit, very small one. Let's learn electronics before we begin. So I'll put LED, and I'm connecting the positive edge and negative edge. First of all, I'm connecting the negative edge to here. The positive edge I can connect this way or this way, anything. Let's connect to this one so it's clear, right? It's clear. Okay, this is negative and positive. I'm taking a battery. There is a coin cell, this one. Again, the plus and minus edges. I'll connect plus into the plus one, then the minus. Okay, if I play this, you can see the bulb light up, because this minus will be connected to the bulb minus, plus will be connected to the bulb plus, and it will light up. But there's a small problem. You can see current through the LED is 61.9 milliampere, while the recommended maximum is 20 milliampere. The LED usable lifetime of the LED may be reduced. So LED will be burned, but here it's not going to burn, but anyway, the lifetime might be reduced because we are providing more current. So how can we control? You can use a resistor, right? You can use a resistor and just give this connection through the resistor. That will solve the problem. If you connect using a resistor, then the problem will be solved. Why? Because when you are giving a resistor, so it will also consume some voltage. You can see the bulb is not that much bright. So let's change the resistance to ohm. And so if 1 ohm, that is still a problem, 58.4. So let's put 10 ohm. Still there's problem. So it's sending 38.9 now. Here you can see 38.9. Actually, the V is equal to IR. I think you know about the equation. So let's increase R. Let's increase R, or the resistance, to 40 milliamp, 40 ohm, and now we can see it's healthy, right? Working well. I just put 40 ohm. So that is enough. That will control this voltage. Can you all do this quickly? Nihan has already done that. Okay, good. You have done the exact calculation. Yes, you can put. So what is the resistance then you put?
150
Can you see the resistance that you put? So click on the resistor. So 150 ohms. That is too much, I think. So just put in 50 ohm will be enough. Still, that is safe, right? Still synthesize. So can you put 30 ohm? Just put 30 ohm, then you can observe, like when you read ducts. 30 ohm is not enough. When you put 30, you can see here 22.6 milliampere. 22.6 milliampere pass through the bulb. Right, that is the issue. So that is why the 40 ohm will be okay. 40 will be okay. So if you increase this, what will happen? So just try to increase. Now make it 100. So see what will happen to the brightness. Brightness reduces, right? Make it 1000. Don't stop. Make it 1000. But you can see still 10,000. Very low brightness. Now erase 0 slowly. First 0 erase, increase the brightness. Second 0 erase, increase the brightness. Third 0 erase, increase the brightness, but this is not safe. The fourth 0 erase, increase the brightness, but it's not safe. So put 40, I think that is okay. That will be. Right. Anyone else wish to share? Anyone else wish to share? No one else has done that. Anita karena the tihan neta kare. Okay, Gaurika, can you share the screen with it? Gaurika, can you share the screen? Don't worry if you have not done, I'll tell you, right? I'll tell you how to do. Can you share? Okay, so when you are delaying, if you have a problem, tell me, right? If you have a problem, tell me. So do you know how to share? You have to use the green color button, share, then share it. If you have a problem, report it. So if you have any issue preventing you share in the stream, tell it, then I know that. So that is saving others' time. Respect others' time, please. So if you are not doing that, that is like you have to respect others' time, right? If you're having a problem, tell me. So that is simple enough. We all can communicate like people, no? We are not from some. We are not like. I hope there are no aliens in the class. Then, as human beings, we all can communicate. Okay, it seems. Gaurika, can you hear me? Can you hear me? So at least send me a message. Okay, send me a chat message at least. Yeah, I'll ask one by one. So I'll give the multiple sharing options, please. Let me give the multiple sharing options. Sharing. Security. Okay, others, can you try? If you're not doing this, so shall we stop from here? So this has not happened in the single medium class when I asked you to share, so everyone share. Nadun, can you? Ashain, can you? Can you all hear me? Lakshya, can you share?
Can hear, sir.
Lakshya, can you share? If you are not done, doesn't matter. Please share. Okay, Nadun has explained his problem. Okay, Lakshya. So this is Lakshya, you need to connect the bulb also. Please connect the bulb, LED. Put the bulb. No, don't put bulb there. So just undo that. You have to connect the bulb there. Eka hari, don't change that. Use this and connect this to the positive edge and negative edge. Do you know? So what is the positive edge? The lengthier one is the positive. Or anode. Anode or the lengthier one is the positive. Move to the edge. Bulb eke agra walata yanna. So move to these edges. Move to the pins. In the bulb you have pins. When you move to the pins, it will indicate whether it is anode or cathode. No, don't connect like this. Don't do that. So it's wrong. The edges. Please go to the edges. Then you can see that. Corners. No, wrong. Keep the bulb here, please. Now, can you see there are two edges or two pins? Click on the pin. Click on the pin of one. That is cathode. Cathode is minus. Anode is plus. Cathode, you have to connect that to the minus. Please connect. Click and drag. Click there and then click on the minus node. No, click on the pin. Pin එකක් 0 මේ තියෙන්නේ පොඩි hole එකක් ඇතුළට ඔබන්න ඕක ගෙනියලා. Just put it in this hole. Right? There's a small hole there. You have to put it there. So that is the negative edge, right? Okay, then take the anode as well and put it into a positive hole. So then the connection will be completed. Because this hole connects to the positive and this hole connects to the negative. If it working, you start simulation and then you can see one in one. So it has less light because you have high resistance. Click on the resistor and change the resistance to, is 2 kilo ohm, no? Change it to ohm level. This is kilo ohm. Change it to ohm. Yeah, that one. So then give some number, maybe 100, 50, 50. 50 would be some average value. 50, it's mediate. It's good. So resistance will control the brightness. If you increase the resistance, so it will less brightness. Put 500 there. So that you can see the brightness is less. 5,000. One more zero, even more. So reduce the number of zeros. Reduce the number of zeros, and you can see the brightness is gradually increasing. But 5 is not safe zone. So 50 will be good. So likewise, okay. This is Lakshay as well. So let me terminate her stream. And who else? So likewise, if you have problems, just dial me. Okay, you have done that. Right, good. Anyone else? 3 students are in the class. Including Nadun, there are 4 students. So is there only 4 students in the class? Rovinu, Taruka, okay, Ashen. I found 5 students now. Good. But the resistance is not enough. Can you increase the resistance a little? Oh, you have to put their number 50. 50. Okay, controlled. Good. Okay, anyone else wish to share the screen? Taruka. Yes, Taruka, may expand the screen. I cannot see. Taruka, expand the screen. I cannot see that. Make a maximize karana window. Please maximize the window. Oh. Taruka, can you hear me? Just maximize the window. Otherwise, I can't see this. Maximize karanna puluwan neda metani. So can you accept my request to simulate? Just accept my request. Okay, I think he has a problem. Then I think Rovinu, Avisha, you need to share. Rovinu and Avisha, you need to share. Okay. Rovinu and Avisha. Rovinu and Avisha. I'm waiting till you. Do you have any problem? If so, please tell me. Tell me if you're having a problem. Rovinu, still I don't know your problem. Others said that their problem. Still I don't know, Rovinu, what is your problem? Avisha, still I don't know your problem. Okay. Avisha, can you play it? So I think the resistance is too heavy. That is why you cannot see the bulb lighting up. Can you reduce it? There is 50 ohms, but still I cannot see. I think the plus minus edges, then the problem. So can you increase the size? Zoom it a little. Or zoom karana bala. Danarina maru kala gahala itu. Epakoda pattu inni. Okay. So can you give me the control? I have requested the control. Okay, I'll erase this one and I'm going to see what has happened. Erase this one and this one. The meage dana eka tiyene palla hai. Okay, the plus edges, the minus edge is here. Then I have to connect the cathode to minus, anode to plus, anode to plus. So let's play that. Yeah, you can see. I think you have connected it incorrectly. Cathode to minus, anode to plus, right? The long edge to plus. Okay, so this works. Anyone else wish to share? Okay, if not, I'll proceed. So what you have to do now, you have to do small work. So can you try to connect 10 such bulbs? Now there is a one bulb. Shall we connect 10 bulbs? 10 bulbs. So that is the usage of, that is the use. That is why we are having, okay, another LED. Let's connect that to the minus edge here and the plus. Now I have two bulbs. So let's add one more. Connecting the minus to this and plus to this. And likewise, can you try to connect 10 bulbs parallelly? That is the advantage of having breadboard. Breadboard will allow to expand your pins because it has many pins, and without soldering, without soldering, you can connect wires. That is another. Without soldering, you can connect wires, and it can help you expand the. It can help you expand the string. Expand the pins. It will help you increase the number of pins and expand it. Okay, please do this now quickly. Need to connect 10 bulbs. This is okay. What you have done is the same thing, that you have connected all the wires. Right, you have used two color wires. That is also okay. Red wire and black wire to connect, identify the plus and minus. That is very good. And but only thing issue there is the battery is not enough. Right, you can see when you're doing this practically, the battery power is not enough. So shall we add two more batteries? 2 more coin cell batteries, and you can parallel it. Yes. Yeah, another battery. That battery, like if you add another battery, the power will be enough. But make sure you have added a resistor as well after adding one more battery. You can add a resistor to control the voltage. First, add one more battery and see. Just put a small amount like okay, 1 ohm. Let's put 1 ohm and see. 1 ohm. Then add another battery. Please add another battery. Then you can see adding 3 batteries will increase the voltage. Sorry, increase the amperage, not the voltage, because you are adding it parallelly. Parallelly add karam volt තුනම තමයි. හැබැයි ampere ගාන වැඩි වෙනවා. milli ampere ගාන. Serially add karam voltage එක වැඩි වෙනවා. අපි බලමු ඒකත්. When you add, you can see the question comes because of the එතනින් එන ප්‍රශ්නේ. Just put 50 ohms, 30 ohms. I think putting 30 ohms will be enough, right? 30 ohms, 20 ohms even. Yeah, 20 one, 10 one. Yes, 10 is seems, yeah, 10 is enough. 5 is even, but 2 ohm. Yes, likewise you can reduce, right? Put in 1 ohm is not enough, right? Put in 1 ohm is not enough. Okay, so you can add parallel batteries and do this. So how can we parallel the batteries? Like, so let me show this. So when you connect batteries parallelly, it will increase the, so I'm adding 2 more batteries. More batteries here. Here to here, I need one connection. Here to here, I need one connection. But adding 3 batteries will definitely increase the amperage. So let's see, this is 40 ohm. So if I try to reduce this and to 1 ohm, you can see. So it is now 52.5 because you have connected 3. So that is 52. So it is like it's getting more ampere than necessary. But to give more strong power, you can increase the. So if you give 2 batteries, what is the amperage? So let's simulate. You can see 42 milliampere, 2 batteries. But when there are 3 batteries, 42 nitibbe, it will be increased to. So now simulate, you can see it's increased to 52. Right, 52 ampere. So this is with 1 ohm. So let's say 1 milliohm. So let's reduce it to really low, 61. It's around 62, right? It's around 60. Because each one will give closer to 20 milliampere. And so here actually, if there's a 1, it will be around. So if there's a 1 also, you're getting some, how, because there are 3 bulbs now. Let's put 1 bulb and you can see how. So then it's very, very high. So it's 104 milliamperes. But when you keep adding the LEDs, it will also share the amperage with. It will share the amperage with the LEDs. So let's add 10 LEDs quickly. 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Then you can connect this. negative, positive, negative to negative, and positive to positive, negative again, positive. You can connect all the LEDs, negative edge to the negative and positive to positive. It's not difficult, right? Okay, let's play the simulation and you can see. So it is like heavier than it is more than the required 26.2. So let's reduce it to 1 ohm. It's not enough. 2 ohm enough. So let's put 2 ohm. That is it's really enough. 2 ohm will control the amperage because you have 10. But if you have another 10 bulbs, maybe 1 ohm even it. Bulb gana වැඩි වෙනකොට ampere consume කරනවා වැඩි වෙනවා. Okay, this is just a lesson about the electricity. So let's learn about the parallel serial connections. So these things you need to learn. So is there anything to measure this? Is there like ammeter, voltmeter? You have a multimeter, right? There's a multimeter. And you can just measure. So let's connect the coin cell batteries and use a multimeter to measure this. So multimeter, if you connect the positive to positive, negative to negative. So let's start and you can see it has 3 volt, ampere, 300 milliampere. 3 volt, 300 milliampere. So let's add another coin cell battery and parallel it. Just parallel it. So when you parallel it, you can see. So this negative edge, you need to connect with the negative edge and the positive with the positive. Let's parallel it and run it. And you can see it is 600 milliamperes. The ampere increase when you parallel it. So when you serial it, so let's try to serial it. Let's have a coin cell battery, another coin cell battery there. And I'm connecting the negative edge to the positive edge there. And then this negative edge, I'm connecting that to the, negative edge of the multimeter. And this positive edge, I'm connecting to the positive edge. So this is serial connection. When I measure this, you can see it is 300 milliampere, but the voltage is 6 volt now. So serial connection will increase the voltage, parallel connection will increase the amperage. Right? So this is basics of these electronic parts. So you need to know that before we implement the microcontrollers, right? Just know the basic electronics. Okay, so I'll stop from here. Good night. See you all next week. So please do this and add it to the book. Then good night.
Good night, sir. Thank you, sir.
Thank you, sir.
Good night, sir. Thank you, sir.